Hello, my name is Abiodun Hanifoshe. Today we're going to be talking about the reactions of alcohols, and that will include the oxidation to aldehydes and ketones, substitution to alkyl halides, dehydration to alkenes, reduction to alkanes, esterification reaction, and the Williamson ether synthesis. And we're going to be dealing with all these reactions in series, and we're going to be diving into the oxidation to aldehydes and ketones just in a moment. In the last class, we talked about the fact that we can synthesize alcohols from the reduction of aldehydes and ketones. In a like manner, we can make aldehydes or ketones from the oxidation of alcohols, basically depending on the types of alcohol that we are subjecting to oxidation reaction. So if we subject a primary alcohol to an oxidation reaction, we're going to get an aldehyde. If we subject a secondary alcohol to oxidation reaction, we're going to get a ketone. But if we attempt the oxidation reaction of a tertiary alcohol, I'm sorry, that is not going to be possible. As you can see on the board, we have a primary alcohol being oxidized to an aldehyde and then to a carboxylic acid. A secondary alcohol being oxidized to a ketone, and there's no further reaction if the oxidation reaction continues. And if we attempt the oxidation of a tertiary alcohol, that is not going to be possible. So basically, there are different kinds of oxidizing agents that we can use to accomplish this transformation. But the common one is chromic acid. And chromic acid can be obtained from chromium trioxide or sodium dichromate. So this is sodium dichromate. Sodium dichromate, and this is chromium trioxide. So basically, if we subject a primary alcohol to an oxidation using chromic acid, we're going to get a chromic ester, and then we're going to get the aldehyde, which is the final product. But this reaction actually involves two steps. The first step is the is the formation of the chromic ester. So basically, you have something like this. You have something like this. This attacks the chromic acid, and there's an acid somewhere, picks up the proton on the acid, and then we have these intermediates. And then water molecule picks up this proton, goes like this to neutralize this, and we have this. Let me draw it here. And then we have this. Basically what we have here. And water molecule comes again, picks this proton. So the step 2 is an elimination reaction. So this goes here, this goes here, this goes here, so that we can form the final products, which are this. So we're gonna, when this happens, we're gonna form the elimination product, the E2 elimination product, which is the aldehyde, this and this. So we're going to get that. So basically, when we have the oxidation reaction on a primary alcohol, we're going to get an aldehyde. This is an aldehyde. And if we do oxidation of a secondary alcohol, we're going to get a ketone. And the oxidation of a tertiary alcohol is not going to be possible. So we can also use other oxidizing agents like PCC, which is Pyridinium Chloroxhromate. That would be this. chlorochromate. This. So basically we can accomplish the same transformation if we subject, say we have a primary alcohol here. In the presence of PCC, we're going to get an halide. So this is an halide. This is a primary alcohol. This is aldehyde. So we have other oxidation reaction, the oxidation methods that we can use for oxidizing alcohols. And there are methods that have been developed, especially due to the fact that chromic acid is toxic and it's not good for the environment. Other oxidation methods have been developed. So in a moment, we're going to look at the Swern oxidation and the Des-Martin Periodinane Oxidation. So I'm going to talk about that just in a moment. In the previous example of oxidation of alcohols, we talked about using chromic acid and PCC as oxidants. Now we're going to look at the Swern oxidation, where we're going to be looking at the DMSO and the oxalyl chloride as the oxidants. So basically, DMSO will react with oxalyl chloride to give the active oxidants. So we're going to have something like this. This is DMSO. DMSO is dimethyl sulfoxide. So we have something like this. This is dimethyl sulfoxide, that is DMSO. And we have oxalyl chloride like this. This is oxalyl chloride. So basically, we're going to have these two react to give the active oxidant. The active oxidant is this. The active oxidant that we oxidize the alcohol to halide is this. Is this. It's basically dimethyl sulfonium ion. So how does this happen? We have the nucleophilic attack of the sulfoxide, the dimethyl sulfoxide, on the oxalyl chloride, and then we have this go here, and then we form this intermediate. Let me draw it here. So we form this. CH3 and then this comes back and the chloride ion leaves. The leaving group leaves the entire molecule, so that we have this. Let me draw it here. So we have this. We have this. And then we have this, the chloride ion that leaves comes back to attack this, and this go like this, and this go like this, and this leaves. So then we have the active oxidants. So we have the active oxidants, which is this, the chlorodimethyl sulfonium ion. So we're going to have this CH3 S plus CH3 Cl, and you can see that we also form CO2 in the process, plus CO plus Cl minus. So we form this, and this, which is what we're really interested in, the chlorodimethyl sulfonium ion. So it's the one that we then react with this to form our desired product. So how does that happen? So let's take a look at that quickly. So let's say we have a primary alcohol, as in this case. So we have something like this. So we're going to have the chlorodimethyl, and then we're going to have, so this is our oxidants. So the alcohol is going to basically do a nucleophilic attack on the sulfur, and then we're going to have these intermediates, this attacks and this leaves. So we have this. We have this CH3, and we still have the plus. And then we're going to have proton transfer, basically. So we're going to have proton transfer. And remember, we're using TA. TA is triethylamine. Triethylamine is a base. So it's going to basically pick up this proton. So let's just represent the base as B. It's going to pick up this proton, and the electron moves on the oxygen, so that we have this. Let me draw it here, so that we have this. So we have these intermediates. I'm going to have to clean this place. So when that happens, so we have this, let me bring this structure here, our intermediate. Let me just draw it here. We have this oxygen, sulfur, CH3, C. So I'm going to need to open this up. So our base is going to, so we're going to have this intermediate. So our base is going to also deprotonate this. We're going to have the deprotonation of this. This is going to be deprotonated. Comes here, so we have this. S plus CH3 CH minus, and then this is going to basically pick up this proton, and this electron moves here and this moves here, so that we form our final product. So we form our final product. Let me draw it here. So form the halide, C double bond OH plus SCH3 CH3. So this is DMS, dimethyl sulfide. So this is the byproduct. These are desired products. So this is how we use the Swern oxidation method to oxidize alcohol, and we can use the Swern oxidation method to do the oxidation of both the primary alcohol and the secondary alcohol, just as in the case of using when we use the chromic acid. So when we use Swern oxidation, we are also going to convert a primary alcohol to halide and also a secondary alcohol to a ketone. And this is just how it all happened. Just bear in mind that the active oxidants in the Swern oxidation method is this species that we have here. This one. Is this species, which is the chlorodimethyl sulfonium ion. So is the primary oxidant, is the oxidant that comes from the dimethyl sulfoxide and the oxalyl chloride to oxidize the primary alcohol to halide, and also if we use a secondary alcohol, it's going to oxidize it to a ketone. So in a moment, I'm going to talk about the oxidation of alcohol using the Des-Martin Periodinane reagents. The last example of oxidation methods for alcohols that we're going to talk about in this series of reaction of alcohols is the Des-Martin oxidation. In the Des-Martin oxidation, we use what we call the DMP reagents. DMP reagents. And this, what we have here, is what we call the DMP reagents. So basically we have, so these are oxidants, and just like in the case of the chromic acid and the Swern oxidation, when we use the DMP, we can as well convert a primary alcohol to an halide, and we can convert a secondary alcohol to a ketone, just as in the case of the chromic acid and the DMSO and oxalyl chloride, the Swern oxidation. So just that in this case, the reagent is different and the mechanism is of course different. So how does the oxidation using DMP happens? So we're going to look at this example. We're going to be looking at the primary alcohol being oxidized to an halide using the DMP in dichloromethane as solvents. So let's quickly take a look at that, how that reaction happened. So we're going to use this same compound here, the oxidants. So let's say we have the aldehyde, the primary alcohol. So it's basically going to attack the iodine, and this goes on this oxygen of the acetate, of one of the acetate group. One thing you should note here is that there are 3 acetate group in these oxidants that we are using as the oxidizing agents. So the DMP, so we have 3 acetate group. So this alcohol is going to do a nucleophilic attack on the iodine here. You can see we have an iodine here. So when this nucleophilic attack happens, the electron in this bond is going to go onto the oxygen of one of the acetate group, and that will leave. And so we're going to have something like this. We're going to have something like this. So we still have the two of the acetate group in place, and now we have the alcohol positively charged. Let me put just the positive sign there, and then we have this so we have the acetate ion in solution. So we're going to have this in solution. So this is going to, this is the acetate ion. So this is going to pick up this proton because it's going to serve as a base. Pick up this proton, and this electron goes onto the oxygen atom, and we have this. We have this. We still have the two acetates in place. And then we're going to have another molecule of the acetate ion. Picking up this proton, such that the electron here moves onto this bond, and this one goes to the iodine, and then this leaves as another acetate species, so that we have the final product. So we're gonna have the final product. We're going to have the final product, which is this compound here, and the byproduct is going to be this. So this is the byproducts, plus we're going to have acetic acid as another byproduct. Actually, two molecules of this will be formed. So we have our main products, the halide, we have the byproducts, and this other byproduct, acetic acid. So basically, when we do this reaction, the oxidation reaction of the primary alcohol using DMP, we're going to get an aldehyde. And if we do a secondary alcohol, in a like manner, if we do a secondary alcohol, oxidation of secondary alcohol using DMP also, the reaction is going to go through the same mechanism, and we're going to get a ketone. And that is how that reaction works. So that is that about the oxidation of alcohol using the different methods that we have in organic chemistry. And today we have used the chromic acid to do the oxidation of primary alcohol to aldehydes, and the oxidation goes further to the carboxylic acid in the case of primary alcohol, and in the case of secondary alcohol, the oxidation ends in ketone. And we say that tertiary alcohol cannot be oxidized. So they cannot be oxidized. So we have appreciated different oxidation methods to include the chromic acid method, the Swern Oxidation method, and the last one that we talked about now, the DMP method. So these three methods are very important methods that we use in organic chemistry to perform the oxidation of alcohols to either aldehydes or ketones. And just as we have seen, we have different topics under the reactions of alcohol to still talk about. And like I said in the beginning of this class, that these reactions of alcohols is going to be in series. And this is the end of the first series, which is the oxidation of alcohols to aldehydes and ketones. So thank you for listening, and I'll see you in the next series of the reactions of alcohols. Thank you. See you in the next lecture. Bye.